Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Okay, Jam. I realized that we've had a few episodes in the last month that came from this same listener. It's Sam N. And I don't know what to tell you. He's just been sending me questions I'm pretty excited about.
Yeah.
So this latest one, he actually sent probably years ago.
Okay.
At least a year ago.
Okay.
Now, Sam N., he's a friend of ours in real life. He's an avid listener of this podcast, and he is an avid hater of cheese.
Yes. This is one of the things that people learn about him first, I feel like.
And now everybody who listens to this podcast knows this about Sam N. So a long time ago, he asked me to do an episode on why cheese is so disgusting.
Okay. And you refused, right?
I straight up refused. I said, no.
Plus, even using the word disgusting in a scientific publication of some kind, even though it's just a podcast, is kind of not a very scientific word. It's an opinion-y word, right?
It is an opinion-y word. He did send me an article from Business Insider talking about some researchers who are researching disgust using cheese, but I didn't really have a chance to look at it, so I don't know. They're trying to figure out what disgust is and where it occurs in the brain.
Okay.
Which is different than having an opinion that cheese is disgusting.
True. So it'd be like, I guess the better way to say it would be like, Sam has a disorder.
No,
Just
Sam
kidding,
doesn't
Sam.
have a disorder. But I did then, I don't know why this came back to my brain this week. And I started to wonder, maybe it's because we had really good cheese when we went to a local charcuterie board restaurant.
Oh, nice.
Or I don't know. I just love cheese. So maybe I just had cheese on the brain.
Yeah.
Okay. So then I started to look into it and I got very excited because cheese is so chemistry-y.
Nice. Dude, I've always been curious about this.
Have you?
Yeah.
Okay. Well, here we go. So cheese starts with milk.
Okay. Did not know that. I'm just kidding. I knew that.
Milk is a bunch of chemistry in and of itself. I mean, I guess everything is, but it's mostly water, but it also has some other things in it like lactose, which is sugar, proteins, calcium, some fats. That's kind of the main gist of what it's got going in there.
Okay.
One of the proteins is called casein.
Okay.
Or casein. I'm not sure. It's casein.
Okay.
And the casein proteins form these things called micelles.
Okay. I feel like I've heard both those words before, caseins and micelles.
We talked about casein when we talked about capsaicin.
Okay. That sounds right.
Casein helps alleviate the heat from jalapenos.
Right. Oh, yeah, because it's in milk.
It's in milk. That's why people tell you to drink milk.
Yeah.
Micelles we have talked about before. In soap.
Right. Okay.
So let's talk about what a micelle is. Okay. Now imagine a molecule.
Okay.
It has a polar end on one side and a nonpolar end on the other side.
Okay.
So we've talked about polar and nonpolar bonds before. A polar bond is what?
A polar bond has a heavy concentration of electrons on one side.
Right.
And so it has, and then not one on the other side, right? So then in terms of it trying to interact with other molecules and stuff, that will affect what it wants to try to connect to.
Yes.
Something like that?
Yes,
okay.
Exactly. It's a polar bond has an uneven distribution of electrons. So one side is going to be more negative and the other side is going to be more positive.
Right.
A nonpolar bond has an equal share of electrons.
Right.
So it's not going to be charged. It's neutral throughout.
Yeah. Just like more chill overall.
It's just more chill overall.
Yeah. I know some guys like that.
So when you get a bunch of these casein proteins together, they're going to form micelles where the non-polar parts of the bond want to hang out together.
Okay.
And so all those will be sort of pointing inwards.
Okay.
And on the outside will be the polar side.
Mm.
And that is so polar, in fact, it's actually negatively charged.
Okay.
Okay, so you kind of have, what you end up having is, now it's hard for me to come up with an analogy for this.
Okay.
So you're going to have to do it.
Okay.
That's your job for today.
Okay.
But you sort of end up with a ball, like a magnet almost, that's negatively charged all around the outside, and the middle of it is neutral.
Okay. Interesting.
Now, the reason we've heard about Micelles before is the same thing happens with soap.
Right.
Soap has a polar side and a nonpolar side.
Mm-hmm.
The nonpolar side loves grease and oil and other nonpolar things that stick to our dishes.
Right.
And so the soap molecules will huddle up around the grease, leaving only the polar side exposed, and the water washes it away.
Right.
So casein does that same thing.
Mm-hmm.
They huddle up together. Their nonpolar sides are in the middle. Their polar sides are on the outside.
Okay.
And they basically end up being a negatively charged ball.
Okay.
Ball of negative charge on the outside.
Got it.
So to get cheese, what basically happens is these casein proteins have to stick together.
Okay.
But chemically, they don't want to because they're all negatively charged.
Right.
Many of us have experienced this before when you try to put two magnets together and the negative charges are on the same side and they repel each other. That's what those casein micelles are doing in milk. They're repelling each other.
Okay. Got it. Tons of just the negative balls that don't want to be around each other. They're looking for positive stuff. That's what they'd rather have.
Yep.
Okay.
So they're not going to stick together, but them sticking together is what we need for cheese.
Oh, right. So then it can be like a more solid thing.
Exactly.
Okay.
Those proteins sticking together are more solid things, just like with eggs cooking.
Right.
So we've had an episode about soap that you can review to get more of an idea of the polar and nonpolar bonds. And we have an episode about what happens when you cook eggs that you can review. I think that one was also from Sam In.
Yeah, I think you're right. Dang, dude.
He's
Sam,
pitched some good episodes.
what a champ.
He knows how to pique my sense of curiosity and get me excited. So to be able to get these casein micelles to stick together, there's two chemistry steps that need to happen.
Okay.
There's probably a lot more, but I'm going to boil it down to these two chemistry steps. Chemistry step 1. Milk has bacteria added to it.
Okay.
If it's unpasteurized, there's already bacteria in it.
Right.
And that bacteria will break down lactose, which is the sugar in milk, into lactic acid.
Okay.
So I don't think we need to get into the nitty gritty of how that happens. But the bacteria basically, as a byproduct, it eats sugar and it spits out lactic acid.
Okay.
So that is a chemistry process in and of itself. That's the chemistry step 1.
Okay.
We're turning sugar into acid.
Okay.
So if you add acid to something, it's going to become more acidic.
Right.
And that's where chemistry step 2 comes in.
Because acids want electrons, right? Okay.
So this acid, which is a positive, is going to sort of neutralize the negative charges on the outside of the casein micelles. And that's going to allow them to stick together.
Okay. Wow. So there's enough electrons to where all those negative, the outer layer, they all have so many.
There's so many negative charges.
And then all the acid that's newly present wants the negative charges.
Yep.
And then everything stabilizes out. Whoa. Cool.
Isn't that amazing?
Yes.
It's so simple, but it's so complicated and so chemistry-y.
Yeah. And to think that, like, obviously, like many things we talked about, that was going on for centuries before anyone understood what was happening.
Oh, 100%.
Cheese obviously happened naturally at some point.
Yep.
And then people were like, this tastes good. Let's keep doing it on purpose. Man, that's cool.
So what this looks like practically, if you've ever seen someone make cheese, they'll have the milk. The bacteria will be added if it's pasteurized, or they'll let it sit. And it will the liquid will start to get more clear and watery looking. And then there will be chunks in it.
Okay.
And those chunks are literally micelles of casein that have started to stick together.
Nice.
And in some ways, I think the the micelles break down a little bit and just the casein proteins are sticking to each other more. It doesn't keep its perfect shape once it doesn't have that charge, I think.
Okay.
So those are called curds.
Right.
So you get the watery liquid, it's whey, it's got some other proteins in it and stuff, and then the casein proteins sticking together. There's some other stuff in those curds too, not just the casein proteins, but the casein proteins sticking together is what starts to solidify it.
Okay.
And then you gather all those up and press them into cheese molds. That's cheese molds like shapers, not like mold.
Yeah.
Yes. Because that comes into play too.
Yeah.
And then they let the cheese age. And the aging process is even more chemistry.
Okay.
You're turning more of that lactose into lactic acid.
Okay.
The bacteria are as it ages. And the more acidic the cheese gets, the more sharp of a flavor it has.
Okay.
And sometimes they will inject strains of mold into cheese to make something like blue cheese.
Right.
So that's the overall chemistry of cheese.
Interesting. Dude, wow. That's crazy.
Oh, they do also usually, after they've pressed the cheese into molds, they'll have salt or something. I think that forms a rind on the outside.
Okay.
And that maybe keeps it from having any kind of aging that you don't want.
Got it.
Basically it going bad in an uncontrolled manner, I think.
Right.
And that's also when the texture is developed as it's aging. So that's the chemistry of cheese.
Wow, dude. I like it. That's interesting.
So the bacteria are causing a reaction to happen. And then that reaction, creating acid, is giving the right conditions for a micelle to lose that negative charge and the casein proteins to start to stick together.
Dang. Yeah. Wow.
Also, the bacteria doing a reaction, that's useful in cheese. People are basically using the bacteria to do their job. But there's actually a professor at UNT named Dr. Liz Skellum, and she does organic synthesis using bacteria. She makes the bacteria make the chemistry for her.
Oh, interesting.
So I think that's another application of a similar process, but this is cool because the bacteria are doing a chemical reaction, and that chemical reaction is creating the environment that we need to make cheese, basically.
Interesting. Wow.
So that's it. That's the chemistry of cheese.
Okay, interesting. I think I might have an analogy, but it's a little bit of a stretch.
Okay, lay it on me. Let's see.
But it can't hurt, you know?
Can't hurt. It can't be better than the no analogy I came up with.
Yeah. So let's say that milk is like this world we live in. We're all just in a big old glass of milk.
Okay.
And all of us are micelles.
Okay.
What I mean by that is that many of us, I guess you could say, let's just take a hypothetical group of people that are not very optimistic people.
Okay.
They're pretty negative, pretty pessimistic.
Definitely.
I can be that way sometimes. Sorry.
I can be that way too.
So imagine a group of people that are all that way in this world of this glass of milk, which is not a stretch. I think that's actually pretty reasonable to view our world that way. So they all have this negative, like, outer interaction layer.
Right.
But if you want to be a little bit of a more optimistic person, you have to believe that there's something inside of them that's a little more chill, a little more tender, a little bit more human, a little bit more not quite as negative.
Right. Definitely.
But how are we going to get there? How can we get to that level? Especially when you have tons of people that are negative like that. They don't want to hang out. They don't want to befriend each other. They want to be on their own.
That's right.
Because they don't want to be around other negative people. They're like, ooh, I've got too many opinions about you. Don't want to be around you. But what happens if you could flood the entire world with something very positive?
Okay.
So in the case of milk, we introduce bacteria. bacteria eats, I don't have an analogy for this part. Okay. So bacteria eats.
Back off, listeners.
Sorry. So bacteria, maybe you could add into this if you're a listener and you're thinking, oh, I've got a perfect addition.
He was just so defensive straight out. He said, I don't have an analogy for this. Okay.
So this part, just the bacteria eating the lactose and turning it into lactic acid.
Yes.
Don't have an analogy for that part. So something really positive happens. Lactic acid is very positive.
Yep.
So imagine just some really good vibes are introduced into the world.
Nice.
Something super positive, love, whatever it is.
Chocolate.
Something that really softens that negative layer that we've got around ourselves.
Yeah.
It neutralizes it. It's just too positive. You can't resist.
Yeah.
And then all that negativity's gone away. And you start to notice like, hey, all these people around me, they're kind of cool. they're not so bad. Let's hang out. And slowly all these groups of people start hanging out because they're not as negative as they were before. They start being able to get along really well. And then they form these curds, or as we call it, like communities.
That's great.
And then we press them into, that's where the analogy breaks down again. Press them into these molds that form the cheese into shapes and age them. And
coat them with salt.
Yeah.
Yeah. I like that. That's a good analogy. I was trying to think of something structural, like a bike or something.
Right.
A bike wheel, it's got that. But none of those really made sense. But I think that does make sense.
I feel like it's structural. Like there's definitely more details to the structure, of course.
Right.
But I did think about how we all have an outer way that we present ourselves and talk and say things that often varies from our inner version. Yes. And again, that kind of personifies molecules and stuff, which we've talked about as being not always everybody's favorite. Not all chemists like that.
Yeah.
But for me,
I like it.
Yeah. And you've said that. Yeah. For me, it helps me relate to it more or whatever.
Well, that's why I like it. I know we don't need to personify them. And as long as we can keep in mind that they are not people, they are atoms and they don't have wills or well, they have excitement, but not the same way we have excitement.
Yeah.
They don't have desire or will. They're kind of like jellyfish. They just float along and experience what happens to them. But if it helps people understand, then I want to use every tool we have to do that.
Yeah.
So I liked this one. It felt like a more old school kind of lesson. One of the more early kinds of lessons we did.
Totally.
And I just thought it was interesting and really fun that cheese was so chemistry-y. I also want to give you some fun facts.
Okay, sweet.
So pH is a measure of acidity. And so cheese starts to form. The micelles start to stick together at around a pH of 5.3.
Okay.
And then it seems like full coagulation takes place at pH of 4.6. I might need some time at that pH, but that's the pH. So that's just an idea of the pH at which it starts to stick together.
Nice.
And softer cheeses are made by coagulating slower. So like cream cheese would be a slow coagulating cheese.
Oh, I see. Okay.
Harder cheeses need to coagulate faster. So those cheeses get something added to it called rennet. And rennet works by sort of snipping the negative part off of the micelles. So they'll come together even quicker.
Oh, interesting. It's got some help.
Got some help. Yeah. So I thought it was interesting. Maybe we can go more in depth on how that works in a later episode or something.
Yeah.
And I also want to say it's not just casein proteins in the cheese. There's other stuff too, but the casein proteins sticking together is what forms the more solid cheese structure.
Okay.
So I think that's pretty cool.
Dude, yeah. Very cool. That's awesome. This was very, very interesting. I think also I'm probably a little bit more partial to any of our food related ones.
Oh yeah.
There's just something about it that's like, one, it's every day, and two, it just food's interesting, you know, but.
And I think that means, food scientists, you guys can correct me if I'm wrong. That would mean that cottage cheese is basically, you're looking at the very early stages of casein micelles starting to stick together.
Oh yeah. Cause there's like lots of little curds.
Huh. you're looking at casein micelles clumped up.
Yeah.
With some other stuff in them, obviously.
Right. But yeah, it looks like so much more milky than other cheeses do. So yeah.
I think that's my speculation. I did not confirm that.
Yeah.
Great. Well, this was a fun episode. So thanks for that, Sam. Do you have any fun things from your week to go with it?
I do. So this week we had a birthday party for my son. And he turned 1, which we talked about, I think, on a previous episode, but we had the birthday party later. Mm-hmm. That was a lot of fun. It was Mr. Rogers themed, which my wife and I love. And
so do I.
Yeah, who doesn't love Mr. Rogers? Basically, all of us millennials have kind of rediscovered him over the past 4 years or so.
He's just so positive. Speaking of something positive flooding the world.
Seriously, Mr. Rogers. That's a great, there we go. Let's take that analogy all the way home. Go watch Mr. Rogers. Go watch the documentary or the Tom Hanks movie.
Either one will get you. Yeah. It's a tearjerker.
Oh, totally. So we had a birthday party. It was a lot of fun. We had some friends that most of them are just people it was a really good excuse to have them come to Denton that don't live in town.
Yes. Yeah.
And then other friends, of course, are ones that we get to see all the time.
Right.
Melissa made some really cool desserts.
Ooh, yeah.
She made some Mr. Rogers sweater cookies.
Those are so fun.
Which looked so cute. And also Mason helped.
Yes. And we made trolleys.
And trolleys, which I think most of the trolleys got eaten first for some reason.
Really? I thought they wouldn't be as exciting because they had less icing on them.
Maybe it's just a little bit less human. I'm not eating. I'm not eating a torso. But anyway, that was really fun. And then Melissa made a cake for him, and he ate it in the most funny way. He ate all of the fruit pieces off first, and then once he had done that, he realized he could pick up the entire cake, and then just tried to shove it in his mouth
because it was an angel food cake, so it was light. That was a request by Jam. That was a good call. The angel food cake was a good idea.
And he ended up loving it, which was awesome. And yeah, it was just so funny. But the whole thing you hope kids do, pick it up and get really messy and stuff, just took him a while to get there because he was ooh, I love fruit. Let's eat this fruit first.
And add some whipped cream too.
Yes. So anyway, it was a lot of fun. I could probably go on for a long time, but it was definitely a lot of fun. So thank you for all the awesome desserts you made.
You're so welcome. It was really fun to make those desserts, actually. So
dang, I'm glad you like it. I'm glad you have fun doing that because that is not, for me, not fun.
I really enjoyed it. And it was fun to do that with Mason too. For a long time, I would just bake by myself. So baking would usually involve staying up late and listening to a murder podcast alone in whatever kitchen. And this time I had company, so it was a lot better.
Nice. And he's good at the icing stuff.
Yes,
too.
He's very artistic. So it was nice to have him around to help with that.
That'd be hard. I'm artistic also, but the idea of trying to be really careful on something like a cookie or whatever, not my thing. So you guys did a great job.
He's good at precision operations. Well, my thing from this week is pretty different. You guys may have seen it already, seen about it on Twitter, but we. So someone in the chemistry department nominated me for an award just because I'm in the chemistry department. Yeah. But for our work on this podcast.
Right.
And the award was granted, which was so exciting. We were given, and this podcast is an award-winning podcast.
Yeah. Dang, that's cool. I like that phrase. That's awesome.
So we were awarded the President's Special Recognition Award at UNT. And I was able to go into his office with my advisors, including Dr. Weber, who, shout out, she is the person who encouraged me to start this podcast whenever I didn't know what to do. And then that's how I ended up talking to Jam. And so she got to come, and my new boss, Dr. Atkinson, she's awesome. And she's been so supportive of me continuing this while I do my PhD work. So it was just nice to get to celebrate that with them there. Yeah. So, and I got a cool award. It's an eagle head. It's really heavy. It's bronze, I think. And it goes up in my office on my desk. And so it's really fancy. It came in this great box. And so there are pictures of it we'll post online.
Dang, that's awesome. Very, very cool.
So thanks, you guys, for caring about chemistry. I'm so excited about that. And that we've been able to do this podcast for 100 episodes, and we're starting to get recognized by people for the positive impact it's having on y'all's lives. We really appreciate this so much and could not do it without you guys. So Thanks so much for coming and learning about cheese today and all the other topics we've talked about.
And Melissa, thank you for teaching us. And sorry, Sam, but I think cheese is a little bit more awesome now than I thought it was before.
Yeah, absolutely.
But all I have to say, Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you guys. Ideas like Sam's question about cheese. So reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Hefner, who reviewed this episode.